For this lesson, I'm going to teach you how to calculate molar mass. For this, you'll need a periodic table, you'll need your calculator, and I have a few examples that we've done in class. When you're looking at an individual atom, you can simply look up on the periodic table. Now that we used to call these atomic mass units, these are known as grams per 1 mole. So the value that you see for the average mass is the grams per 1 mole. So the first example of cesium, you look on the periodic table, you find cesium at 55. It's 132.91 grams per mole. So you simply write down grams per 1 mole, which can be shortened by writing G over MOL. When you come across a molecule or compound, in this case we'll do CH4, methane gas, you need to take an account of all the atoms present. So you have 1 atom of carbon and 4 atoms of hydrogen. So to show the work there, I'll just simply write down all of the atoms present. I'll write down how many I have of each and what the average mass or the grams per 1 mole is off of the periodic table. So I can find carbon on the periodic table and I write down 12.01. I have 1 atom present in methane gas, which is just equal to 12.01, and the unit is grams per 1 mole. Hydrogen is 1.01, so I'll write that down for hydrogen. I have 4 atoms of hydrogen. I'll put the total after I multiply, and it's grams per 1 mole. To get a total molar mass of methane, you add the two values together, giving you 16.05 grams per 1 mole. So further, if you get a compound or molecule, in this case plumbic carbonate, you need to remember how to write the formula. So practicing writing the formula, plumbic is Pb. There's a +4 charge. Carbonate we'll put in parentheses because it's a polyatomic, and it's a -2 charge. When we cross down the values only without the charges, you notice that there's a 2 and a 4. We need to make sure that we reduce this. So your final formula should look like PbCO3 in parentheses and a 2 outside the parentheses. What that means is that we actually have 2 carbonate molecules. So you would distribute this 2 and you would have 6 oxygen, 2 carbon, and then 1 lead. So you look up on the periodic table, you find Pb is equal to 207.109, and you have 1 of them. You then have your next atom, carbon, on the periodic table, 12.01, and you have 2 of them because you've distributed. And again, these are all grams per mole. Oxygen is 16 on the periodic table, 16.00. And you have 3 times 2, which is 6, giving you 96 grams per mole. Adding them all up, you have 327.21 grams per 1 mole for plumbic carbonate.